All right, welcome to section 4.2. Our essential question today: how do the characteristics of a quadratic equation help us graph the corresponding parabola? One of the things that we're going to look at today is called vertex form of a quadratic function. And in vertex form, it's always in the form y equals a times the group x minus h squared and then plus k. So this is helpful for us because the variables h and k, they're going to tell us where the vertex is. Whatever our h value is, that's going to give us the axis of symmetry. So we'll say x equals h, again, whatever that value is. You may have learned in algebra that if a is greater than 0, you have a smiling or an open up parabola, and you have a frowning or an open down parabola if a is less than 0. So let's look at an example. We'll zoom in a little bit for you. Step 1 is that we need to identify what the constants are. And by that, I'm really just talking about what is h and what is k, what is our a value. So we have a, that goes out in front, that's 1/2. H is what's inside of parentheses with the x. And remember, we are subtracting h, so we have to change the sign. H equals 3. And then k is at the end, so k equals -5. Step 2, we're going to plot the vertex. The vertex is always what h and k are. Here's our x value, here's our y value. So our vertex is going to be at 3, -5. And you can go ahead and plot it. Step 3, we want to evaluate 2 more values for x. So I'm going to create a table, x and y. I'm going to put the vertex right in the middle. And it helps if you have the integer numbers. So I want to try to make this, because we're going to end up multiplying by 1/2, I want to try to make this so that anything inside of parentheses is an even number, because when you're dividing or multiplying an even number by 1/2, it's going to turn out to be those integers. So you can go straight down to 2 and use your calculator to help you. I'm actually going to jump over 2 and go to 1. Because when we substitute 1 into the equation, I'll do that off to the side. We're going to have y equals 1/2 times 1 minus 3 squared minus 5. If you do 1 minus 3, you get -2. -2 squared makes 4. And then 1/2 of 4 is 2. 2 minus 5 is -3. So now I'm going to jump over 0, and I'm going to go to -1. And you can check my work on a calculator, but when you substitute -1 into the equation, you should be getting 3. So the whole reason we're talking about the axis of symmetry is because that can actually help you plot points. I'm going to graph the axis of symmetry. The axis of symmetry is the equation x equals whatever our h value was, which is 3. So I'm going to draw a dotted line through the vertex. I'm going to plot those other points that I just calculated. 1, -3, and then -1, 3. And the reason it helps is because now I can see the vertex is on the axis of symmetry. For 1, -3, it's 2 spaces away from the axis of symmetry. So I can go 2 spaces in the opposite direction and plot a point. Because for the axis of symmetry, points are going to be the exact same on either side of the line. So when I plotted the point -1, 3, I count how far away it is. 1, 2, 3, 4 spaces from the axis of symmetry. So I'm going to go 4 spaces to the right. And I know I have another point there. And on my table, I can include those points. So we should have 5, -3. Then we should have 7, 3. And the last step, connect your points. All right, let's practice another one. Step 1, you want to calculate what the constants are, figure out what the constants are. Our A value is 2. Our H value, again, you have to change the sign of what we see here. So our H value is -3, and then our K value is 4. Step 2, you want to plot the vertex. And again, the vertex is always H, K. For us, that's -3, 4. And then right now, if you want, you can draw that axis of symmetry directly into the parabola. X equals -3. Next, step 3, we want to evaluate for 2 more values of x. You want the vertex to go right in the middle. If you substitute -4 in, you should be getting a value of 6. And if you substitute -5 in, you should be getting a value of 12. Plot those other 2 points. And then use the axis of symmetry to help you plot 2 more. So with the point -2, -4, 6. I count 1 space over to get to the axis of symmetry. So I can count 1 more space to the right. We have to count 2 spaces away. So we count another 2 spaces away from the axis of symmetry. All right, next. What happens if we're in intercept form? Intercept form will be written in the form y equals a times the group x minus p times the group x minus q. The x-intercepts are going to be whatever p and q are, and the axis of symmetry is going to be halfway in between them. So to find the axis of symmetry, it's going to be the equation x equals p plus q divided by 2. We're going to use that midpoint formula that we learned in geometry. The graph will be smiling or opening up if a is greater than 0, and it will be frowning or opening down if a is less than 0. So let's look at the first example. We have y equals 2x plus 4, x minus 6. Now, if you go back, you'll be able to see it was minus inside of parentheses. That means you're going to have to change the sign of whatever you see. So it says find the x-intercepts. We have p equals -4. And then we have q equals 6. Because we have to change the sign. Step 2, we have to find the vertex. So that's where you need to use that midpoint formula. So we're going to have -4 plus 6 over 2. -4 plus 6 is 2. There's our axis of symmetry. So then if we're going to find the y value of our vertex, we need to substitute 1 in place of x and then solve. So we'll write y equals 2 times 1 plus 4 times 1 minus 6. So we're probably going to want to use a bigger scale than just 1 if we're trying to graph the point 1, -50. So for the y, I'm just going to count down by tens. But x I'm going to keep as 1. So we're going to go to 1 and then down 50. So it's really like going down 10, 20, 30, 40, 50. And I'm going to plot a point. So next we want to find a few other points. And if you try to plug this in and you try to add just 1, like if you tried to find what the y value would be if you substituted 0 in place of x or 2 in place of x, it's not going to change very much. So I just chose a number. I just counted by 3s. The vertex should go in the middle. I'm going to include -2 and -5 on my table for the x coordinates. If you plug those in a calculator and you simplify them, you should get -32 and 22. So I'm going to go ahead and plot those 2 points. And again, remember, we're using a scale of 10, so it should be just below the 30. And then same with when you plot -5, it should be just a little bit higher than 20. The axis of symmetry is still going to be right in the middle. So because we are 1, 2, 3 spaces to the left at the point -2, -32, you're going to go 1, 2, 3 spaces to the right to get 4, -32. And then count again. You're 6 spaces to the right for the point -522. So we're going to go 6 spaces. Sorry, I said right, I meant left. We're going to go 6 spaces to the right for the point 722. All right, so that's all for video number 1. This is the example we'll pick up with for video number 2.